Hello everyone, welcome to my Solidity tutorial. In this tutorial I'll be explaining you how I made this crowdfunding contract, and with these features we'll go along we'll also dive into these basics of Solidity. So yeah, I used Remix for this contract. Remix is an IDE that it's like a text editor so for Solidity, and it lets me test the contracts I make and compiles it, so it's easy to use it here. And if you are a beginner, you can just open Remix on remix.ethereum.org and just play with it to get familiar with it. Right. So, this is a funding creator contract. This contract basically creates this contract. I'll explain you why I made this later. So basically it just so suppose I want to create a funding a crowdfunding a crowdfund for someone, right? So I can just use this creator contract instead of this whole contract. So if someone else is using it, so, oh shit, okay, never mind. So let's start with crowdfunding contract. That's I declare a mapping here. A mapping is basically a way uh, to add metadata, you can say. So for example, a data about data. So this is the data, and this is the data about data. Event is unsigned integer, and address is like these are data types in Solidity: address and event. And this is a public, so it means that anyone from outside can access this variable, that is contributors, this mapping variable. And these are a bunch of variables. I'll explain what they do. So address public admin, address is the type of variable. Solidity is a statically typed web page, where statically typed language, statically, right? So it's a public variable, so that means that anyone can access it, and it's admin is the name of the variable. And then event, number of contributors, so this variable will record the number of number of contributors uh, who contributed to our campaign, or whatever you can call it. This is the minimum contribution. I think I'll remove this thing later, and we'll also go through an evaluation of wait,
Amelioration.
amelioration of this contract. I'll remove different variables and try to make this better. So event public minimum contribution is the minimum amount of contribution someone needs to do to donate, and this is the deadline. Deadline is an important thing. This means that this decides the duration of our funding contract, and this is the goal. This is the goal of amount of our crowdfunding, and this is the raised amount. The raised amount is like the amount we received. So here we have a struct. A struct is something like a mapping. For example, this is a person. Let's say this is a person. So we can add the person's age, the person's address, or the person's gender, and like data. This data for a data, right? And mapping is somewhat similar. That's how I see it. I'm not really sure if it's the same or not, but it's somewhat similar. And so here we have a request. I'll explain what a request is later. We have a bunch of events here. I'll skip them too as of now. And mapping, we have another request. No, I'm not going to request now. So this is a constructor. A constructor is uh, what it does. It when a contract is deployed, the constructor is triggered once, and it can only be run once. So it helps to construct the contract, you can say. So this constructor takes a few parameters. This is the deadline. This is the address of the account. I'll explain the address of the account when we go through this contract. So this is the deadline. So when someone deploys this contract, he or she gets an option to decide the goal. You can see here, decide the goal, and then the deadline here. Deadline goal and EOS will skip as of now. So the goal is it's underscore goal. So underscore goal star 1 ether. So whatever value here is. So a smart contract in Ethereum basically communicates in way. Way is way Ethereum. Way is the smallest denomination of Ethereum, Ether, and 10 to the power 18 way is equal to 1 ether. So if someone wants, for example, 30 Ethereum in the goal, so if this thing is not there, there will be 30 ways. So 30 ways, like 30 ways, it's nothing. It's nothing. Gas fees is more than that. So it does not make sense for us to make the user type in way. So we multiply whatever the value is with 1 ether. So goal is equal to goal underscore goal star 1 ether. This is the deadline. Deadline is block.timestamp. Block.timestamp is a global variable. So like Ethereum is on a blockchain. So block.timestamp tells you about the time on the blockchain, you can say. Let me just explain it better. Block. I'm sorry. What is block timestamp? Whenever a node connects to it, gets UTC, it stores its so it's a way for us to actually just compare the time. For block.timestamp is something for time here, right? So let's get into block.timestamps documentation for a minute. Block can be manipulated by, it cannot be stamped. Oof. Block.timestamp. Oops. Solidity. So let's block.timestamp is records, I think. Oh yes, I remember what it was now. Block.timestamp current block time as seconds since Unix epoch. So it's a pretty funny thing. We have to calculate the days or the amount of time according to the seconds. So the current Unix time. So 1624303356 is the block.timestamp as of now, and it's the number of seconds that has been passed after Unix.epoch time. Yeah, you can say that. So this is epochconverter.com is a good way for us to calculate the time here, and block.timestamp is just it's just like now. So whatever, it's similar to the now variable in Solidity. It just tells whatever time it is right now, and then we can add some seconds or some data here. So I'll get a better idea of deadline after I deploy and test the contract in front of you. Minimum contribution is 100 way, like I said, way, and 100 way is like two less. Like even less than the gas fees. I think. Yeah. So here's the function contribute. So this is a contribute function. So whoever wants to contribute to our campaign, he or she require block.timestamp is should be smaller than deadline. Oops. So this means that the deadline shouldn't have passed before someone donates. So deadline smaller than block.timestamp. Right? Deadline has passed. Require msg.value greater than equal to minimum contribution. So minimum contribution which we set should be greater than msg.value is again a global variable. It just represents the value of the user, of the which the user is transacting. MSG represents the message dot value. So message, MSG is message, so the value of the message. So however much the value is transferred, right? Minimum contribution is not met if the MSG dot value is not greater than or equal to minimum contribution, right? So if contributors MSG dot sender is equal to 0. So if the contributor hasn't contributed before, so we declared a mapping here, right? So mapping is like a data for a data. So the the word should have been like contributions. I think I made a mistake here. MSG dot sender here should the array it's like an index. So the contributions of msg.sender should be 0. So if it's 0 and he or she donates, then you can add their place in the array. That means plus plus. So the number of contributors increase, right? I hope it makes sense. The contributors message. So this increases the contributions. So the contributors of msg.sender plus it's like writing just a second, contributors msg.sender it's like plus msg value. So it's like this line is similar, is the exact same as this line, right? So raised amount, the value here is added to the raised amount to the total amount, and this emits is has something to do with events. So I'll be explaining events later. So let's skip it from now. So there are two or three ways. I think there are three ways for a contract to receive value or ethers. So first is a payable function. So someone will have to, when this contract is deployed, someone will have to select the contribute, and of course we'll have like an interface to do that. But someone will have to select a contribute function, and then what if someone sends ethers directly to the contract's address? So if this contract doesn't have a receive function, the ethers are lost. So it's like they're lost. Wow. So we have a receive function here. So if someone directly sends ether to this contract, then we run the contribute function. So it's the same as selecting the contribute function directly, right? So yeah, and this function is a get balance function. Get balance function is public. That means anyone can use it. View is a really important thing here. View means that this function is not in any ways playing with the blockchain, like modifying the blockchain. So it's not costing us any gas. And this returns like you have return functions in JavaScript, right? So this returns, and this is the data type it returns. Event is unsigned integer. You can read about what the difference between an unsigned integer and signed integer is on the internet. Signed integer is not. Yeah, they have some range difference. So yeah, return address this dot balance. This is a good way to return address. Address is this, like this means this, like the contract. So this dot balance, so it returns the balance of this contract, and this is a refund function. So we have a logic here, and we are not, and I'm not sure if this needs to be changed. So this means that if some contributor, and generally a contributor is not allowed to uh, refund the amount he or she paid. So require block.timestamp greater than deadline and raised amount is smaller than goal. And this line means that if that this allows the contributors to refund their money if the deadline is passed. If the deadline is passed and raised amount is not equal to, is smaller than the goal. So if the deadline is passed and suppose we want to raise $1,000 and for in one day, in 2 days. So if after 2 days later we are able to raise only $500, so this allows the contributor to refund the money. I'm a little dubious. This looks a little dubious to me, and I'm not sure why I would why I would implement this. But I am thinking about changing this. So, like, just let me know if you have any better ways to uh, help me work this out, to help me get a logic and make this thing as unique and as convenient as possible. So address payable recipient is payable message dot sender. So this means that address is the data type. Payable is another modifier, you can say. That means that this address is payable. That means that this thing can be paid. So this is payable and message dot sender. So we tell them that message dot sender is payable, and we make this payable by using this. So we declare a recipient here, whoever this was. So event value is equal to contributors dot message dot sender. So here we check whatever the contributor, the refund requester donated. So this we check this contributor's balance and however much he or she donated, and then we transfer the value whatever he or she donated to his or her address. So and then we make their balance back to zero. So they cannot they cannot take the money twice, if that makes sense. So a modifier only admin, and this means this is a modifier. Modifier is a require function, but if a require function is used like more than once, so and to make the code more uh, clear and simplified, so we declare a modifier function. This modifier function is only admin. So admin is the one who is, in this case, the one who deployed the contract using the funding creator contract. So admin is the one, yes. So this requires the msg.sender. Whoever msg.sender is, whoever is sending the request, is equal admin. Admin was declared here. Admin was declared in the constructor, so the admin cannot be changed. Admin is fixed. So yeah, it requires, and only admin can call this function. So this is an underscore and a semicolon. This is required in a modifier function. Just to tell them that the code needs to be, it's like, yeah, it's required. Ask Vitalik Putra why it is. So function create request is string memory description. Memory is uh, there are two storage variables in solid. There are like, I think more than two, but these are the main two. Storage is everything here was default as the storage. The storage is, I think, the default here, and string is memory is like a RAM cache, you can say RAM, and this is the ROM. So whatever here is storage is saved in the blockchain, and this is just stored outside of the blockchain. So if you are using memory, it doesn't, I think, cost gas. And gas is something really important here. View function means that we are not a view function has gas benefits too. So like if you're just uh, looking at the blockchain, we are not modifying it, it doesn't cost us any gas. Gas is like a transaction fee used if we add something or if we modify something. If we like add something, we cannot modify blockchain, but if we add something, we need a view function. No, if we add view function like saves a lot of gas. It doesn't require gas. It means I mean doesn't require gas. I'm sorry. So the next one is address payable recipient. Recipient is the next payable. I think you know what payable is now. And earned dot value. So this is a create request function. So what create request function means is the whoever put this campaign, whoever like posted this campaign to raise money for a reason, request is requesting to uh, claim the money, to withdraw the money. So the special thing about this contract is what this create request does here. So in a conventional way, like in a regular crowdfunding platform, the admin, the whoever created had a good right to anytime withdraw any amount of money he or she was able to raise, right? So this kind of creates a trust aspect here, you can say. Trust, no, trust. So create request is used for creating a request by the admin to withdraw the money. So string memory description, this description is the reason for why the creator, the admin, wants to withdraw the money. So suppose it was raised for a good cause they want to feed dogs. So we the description can be to feed dogs, right? And this is the recipient. So this is where the admin decides who gets the where he or she, where the person withdraws the money, where he or she receives the ether they were able to raise, and this is the value of the ether they want to withdraw, right? So public, this is a public function, and here's the only admin here, only admin modifier. So this means that only the admin, only who created this contract can do this. And then request storage new request. Oh yes, so let's get back to request, which I skipped. So here is a request struct, like I explained what struct is, right? So this request has a few metadata. This is the description of the request, this is the recipient, this is the value, and this is the status. This is a boolean, like boolean is in programming true or false. So by default it is false, so it's not completed. And event is number of voters. Yeah, so I also forgot to tell that we have a voting system here. So what this does is number of voters, and the voters mapping. This does it. This makes the withdrawing system and this gives the withdrawing system in the hands of the contributors. So the contributors are allowed. So the if if the admin is allowed to withdraw the money or not is uh, is decided by the contributors here by a vote. So this creates a good, I think, trust here, that a good trust aspect here, that whoever contributes the money has a vote, and he or she is able to decide if if he or she finds that this person is not doesn't seem as good as they thought, or this is fraud, or they just feel like they don't like this person, or the cause is like completed and they don't, like, there are a lot of reasons, so he or she that can just vote no, right? So here's the number of voters. This is quite obvious what it does. It's the number of voters, right? The number of voters who voted yes, who would allow the and this is mapping address boolean, that is voters. So I explained you the request thing here, and I think yes, this is, yeah. So a person can actually create multiple requests for different amounts of money. So, for example, if an NGO is raising money, and they have like different things they can do. They are different fields they are working in, right? So, and they have different fields they are working in, so they can create multiple requests. For example, if they want to feed the poor, or if they want to feed dogs, or if they want to like build a school somewhere. So this they can create multiple requests with multiple descriptions and multiple amounts of money they need. So it's something somewhat like a DAO. DAO also works in a similar manner, somewhat, if I see it, like, it's just how I see it. Don't go against me. So joint public num requests, and this is the number of requests. So yeah, and refund we no we refund we did the refund. So this is creates this request is the struct we declared here, and this storage, this request is created in the storage, and there is a new request variable, and this requests is the num requests is the number of requests. This is the this is the array. This is the array kind of mapping here. So this mapping is to is leads to like is a struct, right? This number is mapped to a request. So this is like the, yeah. I hope I hope I'm able to explain. Hope you get what I'm saying. So requests, this num request is used as the index here, and then the number of requests, if we request here, the number of requests are increased by 1, that is plus plus, and the number of the new request dot description is underscore description here, that is this, and the new request recipient is the recipient here, and the new request dot value, this is like the we're declaring the struct's value. So the it's underscore value and the value here, and the new request dot completed is false, that was already false, and the new request number of voters is 0. So here we emit an event, which I'll explain later what events are. So this is the vote request. So this is public, and this requires whoever is this is what allows a person to vote for the request. So this takes a parameter which is request number. So one can just see the request this number and just vote for it. Vote if they like want the contributor to withdraw the money or not. So require contributors message MSD or sender is greater than 0. So this means that like they'll have to be a contributor. So they'll have to have a contribution that is greater than 0. And request storage dot request. So then here we request we do the same thing. We do the same thing we did here, and then this request is this request is accessed, and the request number is given here. This is like works as an index, and require this request dot voters msg dot sender equal false. So this means that the msg dot sender should not be in the voters array. For voters, you know what voters is? This is the voters array. If only I had a good explanation. So yes, uh, this is the voters array, and they shouldn't, like, it should be false, and if it's not false, you have already voted is the message. So so this just means that this just makes that they have voted true, and adds the number of voters. It was not complicated to mess with the number of, or to add a vote here. And this, when the voting request is completed, the main function, that is make payment function, is used here. So make payment function takes a request number of, and only the admin can access this make payment. So require, it means that the raised amount should be greater than or equal to goal. This requires that the raised amount should be greater than or equal to goal. Request storage plus request. So this is the same thing here. Well, we have been doing since the past three functions. We request the requests. We request the access to these requests. So yes, we request this access to this request, and then we just access this request. So require this request dot completed. This request should not be completed, and then this require. This is the main thing here. This requires that this request dot number of voters should be greater than number of contributors divided by 2. So this means that for years, this means that the number of voters should be greater than number of contributors divided by 2. So this means that 50% should have voted for a yes here. This request dot recipient dot transfer this request dot value. So what this does is this transfers the value of this request to the recipient, and then this request dot completed is equal to true. So I think we have covered everything after except events and this thing here, and we are yet to test the contract. So let's get into events. Events are a way for the developers, you can say, or it makes it easy for the developers to update the interface. I'll be able to explain this better if we have event is an inheritable member of a contract. An event is emitted if it stores the argument of past interaction. These logs are stored on blockchain and are accessible using the address of contract. Yes, of course. So these events are used to create logs of something, to create logs of activities, you can say. An event is generated and is not even the one. It's generated and it's not accessible from within the contract. But so this is, for me, this is useful uh, to actually be able to update the interface when an event is triggered. So when a contribution is made, I'll be able to call a JavaScript function and declare a callback function and update at the interface, the front end. So these is what events are used for in simple words. And let's get to the funding creator. So this is a contract. This is a smart contract. Now what happens is if we give the smart contracts ABI or this the access to the smart contract to someone else to create a campaign for themselves, they'll be able to actually manipulate all of the code and just um, make just customize it and like use it according to their will, right? So like they can just make their own, right? Why take ours? That's not actually the case. So if you're planning to build a platform where uh, people can create uh, their own funding smart contracts, but they they should be able to we should be able to bind them to our contracts rules, right? So what we do here is we create another contract that does that just that simply creates this contract without giving the user the access of this contract. Like it creates it for them to be simple, right? So this contract creates another contract, creates our funding contract for them. So it's not it's, so crowdfunding, public fundings. So this creates an array of fundings, and then this is the create funding function. So yeah, here comes our EOA also. So this create funding thing requires a few parameters here, few inputs. So this input goes directly to our constructor here. You can see the input goal and the input deadline here. So when we create a new create funding, we create crowdfunding, new funding, uh, and then we create a new crowdfunding. Crowdfunding is this thing. We put the input goal, that is this, into this. So this goes directly to the constructor here, which is the goal, and then the input deadline. This goes directly to the and this is the MSG.sender. So whoever uses this funding creator contract is the admin of this this crowdfunding contract, not us. So you get what I'm saying, right? So and then we just push this thing into the fundings array. So what exactly happens here is um, when this when someone uses we cannot actually just so for example, let's take a situation where one of my friends one of my friend asks me to create a funding for him, a crowdfunding campaign for him, and then what I do is I just take my contract and I just deploy it. So here, who is actually the admin here? I am the admin, but I want my friend to be the admin, right? So how do I make my friend this friend to be the admin? So well, if you think about it, I can just directly add his address here and just take his Ethereum address and make him the admin. But but what if it's someone I don't know, and right? What if someone random, some stranger wants to use this contract to to create his or her to create own uh, crowdfunding campaign. So the other option is that we can give this contract score to someone else, and they can just deploy it themselves to be the MSD.sender. But then they are able to actually actually modify this contract code and like, use it according to their will. What if they remove the refund function here and they just not let anyone refund the thing? So we want our whole platform to have a certainty and have a trust, right? So that's why this funding creator cap this is done. And this also lets the whoever creates this contract be the admin, so they have all the access. So yes, so we're done with we're done with learning about what the contract does and how it functions. I'm also planning to add like some variations here, and there may be a lot of vulnerabilities as of now. So let's get into testing this contract. So I might have not explained the pragma solidity, but I'm assuming you know what pragma solidity is. Like an identifier that is used to identify Solidity's version. So this means that version here can be 0.6.0 and 0.9.0, and this is the license identifier. You can just copy it from these samples, the sample contracts. So um, yes, we have this, and this I turned on the auto compile, so this contract is compiled. Thank you so much for watching. I'll make another video explaining its testing it and explaining it the contract in a Solidity developer's point of view. So this was for someone who doesn't know what Solidity, like who doesn't understand Solidity. So right, okay. So thank you so much.